Okay. As I was saying, I welcome you for today's class. We shall be talking more about, we shall be recapping some key issues that we did in the last session in regards to analysis. Okay. Analysis. Then also we shall be talking more about the errors that you've been facing in the due course of your, as you're doing your deliverables. There are those errors that keep coming. So today is the time that we shall be handling all those errors so that you get to know how you can go about with each and every error and what does the error mean. If this error comes up, what does it signify? Where could the problem be when such an error comes up? So that is majorly what we are going to be looking at today. From the actually the errors we are going to be looking at today goes as far any error that you might be facing in the robot analysis. Okay, in case maybe during modeling you got an error, yes, assigning the loads, if you got an error when you do all those other errors that you could have faced, we shall be going through them today. And I hope we shall have a good time and we shall learn a lot from today's session. That's why it was, sorry about that. That's why it was highly encouraged that all of us attend today's session, because it is very crucial. Because if you cannot know why such an error is coming up, it becomes very hard for you to progress. Okay, you might progress, but when you have issues somewhere, you might have left an issue somewhere, or maybe you have not resolved the real reason why the error is coming up. So it becomes a problem on your side as a structural engineer. So it is always very critical to take keen note on the errors that come up when you're doing your modeling analysis and design. It is very key in the robot class. And also one other thing I want to encourage us. I see very many people are submitting in their deliverables, and people are actually producing very good work, which is something very promising. I want to encourage us to continue giving in our very best. We give in the time, we give in the effort, we go even extra miles to discover more things in the software so that we become very good and better in every single thing that we do. Okay. So that is it from me. That's what I wanted to bring us up to, what we are going to be covering today. And let me see, we have not yet reached quorum. I really want us to be here today and we cover a lot. Okay. So before we start today's session, I would like to hear from a few of us how they've been progressing and how far with the robot class. Last time we covered majorly, we talked about, we did majorly load combinations, then analysis. I don't know how it went from your side. Moses, please mute. Engineer Moses. Okay, thank you. All right, I want to hear from us. How have you been? How far with the course from the last session? Have you tried to move on? Have you progressed a little bit somehow, somewhere? I'd like to hear from us. The floor is open. Before I introduce the other captains that are with us on call, so that we begin today's session officially. Yes, Benja.
Good evening, Captain Dale Gracious and everyone.
Good evening to you.
Mine is in regards to, actually I have two issues I'd like to talk to you about. The first one is in regards to meshing. There are times when you're told, like after you've meshed the first time and then you do another verification, you get a warning of an incoherent mesh. And from the previous, I think it was 2 sessions back, we're told to take time and look through an incoherent mesh on a slab. Probably you may find that the slab was not meeting the beam, or there was something you did wrong. But is there a scenario whereby you can check all those issues about the slab not meeting, or maybe you didn't design it as a shell and the slab is satisfying all the conditions, but it's still producing an incoherent mesh. Because I've run into situations like that, and I don't know if there's an error that I'm not seeing, or maybe it is something to do with the software being too sensitive. And then I also wanted to inquire if the positioning of the columns can also cause an incoherent mesh. The way we position our columns, can it affect the way the slab is going to be meshed? Thank you.
Okay. Thank you so much for that question. You talked about the incoherent mesh, then also a way of doing a general checkup on the slabs. Okay, I got that. I've noted it down. Then you also talked about the issue of columns, if they can also cause they also have a play in the incoherent mesh error. Thank you so much, Benja. That one we shall go through and we shall give you. I hope you learn a lot from today's class. Any other person? Can I hear from someone?
Yeah, good day, Captain.
Good day. How are you, Bello?
I'm fine, and you?
I'm okay. Thank you.
Yeah. Yes, the complaint I have is about my own software. I don't know if I'm running some verification, or I just want to move like a panel and I wanted to correct it. So I want to move it. Then I'll just see that my software will just tell me Autodesk report error or something, will just off. Then I need to restart back again. I don't know the reason why.
First part of that again. What when does that come up when you're working on your software?
Especially when I was doing this aspect of this verification and the load
Verification. Okay.
yes. So
What
now,
does it bring
so
up?
now it will just the software will just write Autodocs something error, then it will be very fast. I will not be able to read the content of the message. Then it will
Okay.
just go by himself.
Okay.
It will
I
just
think
say Autodesk error report.
okay. I think I got your question right.
All right.
All
Thank
right.
you.
Thank you. All right.
Yeah.
Thank you so much, Bello, for that. Yes, Melissa.
Good evening, Coach.
Good evening. How are you, Melissa?
I'm good, Coach. I also wanted to say I'm also facing the same error that Bello is facing. I first had the problem when I was dealing with correcting panels, right? Those errors that we ran first, and I contacted Wes and he tried to correct them. And now, when I try to correct, like when I put my mesh and now try to correct those panels, when you try to move, like I don't know that node that comes out, it just sticks, like it freezes, and then it closes way
Okay.
and gives you that error message. So I'm stuck there and I can't even I'm now behind. So I no longer know what to do, of which Wes is also busy.
Okay. I think I've got your query. It actually comes along with the one for Bello. It's in the same area. Okay. Let me just take just some two more people. Then I introduce the other captains that are on call so that we begin. I think we shall start with these ones that we have taken up. Any other person?
Okay. Evening, everyone.
Good evening.
This is Horace from Kenya. I'm sorry to take you behind. I know it's maybe you've covered it, but it's one of the when you are doing the first, what is it called? The first analysis. When you run the first, is it an analysis? Oh, yeah. There was an error on properties columns when your columns doesn't have properties. So I followed the video to correct, but it keeps on every step. Yeah, it keeps on bringing the same error properties. So if maybe I'll share my screen if there's a way, maybe or something I'm missing. I've been stuck on that.
Yeah, when we reach your point, I think you'll share your screen so that we can guide
Okay.
you accordingly.
Okay, thank you.
Yeah, just be on standby.
Oh,
You'll share your screen when the time comes.
okay, thank you.
Okay. I have Tom. I see your hand up.
Oh, good evening, Captain.
Good evening. How are you?
Yeah, good.
Thank you.
Now, I gave Engineer Gatimo my deliverable to review, but he realized that I didn't have self-weight on my structures among the
Okay.
loads.
Okay.
Now, I tried to delete the self-weight in the list. I tried to put it back, but when you try to check whether it has loaded zero, I was wondering, do I have to remove all the levels I've created? I go back to level 1 and I start loading this structure fresh, or there's another way
Okay.
to bring back the self weight of the structure.
Okay.
The
Initially,
rest of
did you
the
have?
loads are on.
Okay.
Yeah, initially I had, but I don't know, maybe a long way as I was doing meshing, what maybe I could have possibly erred somewhere.
Okay. I think that we shall show you how to do that. Let me take just
Okay.
one more person, then we can start with this set of queries that have come up. Anyone? Godfrey, I see you unmuted. Okay.
Maybe I can use this opportunity to ask. My name is Philip from Kenya.
Yeah. Yes, Philip.
Yeah. I just wanted you or the presenter to kind of summarize on the logic of wind loading in this program, in this software, because I find it interesting. I'm an frequent user of ETABS, and I find this interesting to use. So maybe if we can recap in very brief manner how wind loading is applied to the structure.
Okay.
Yes.
All right. Thank you so much. I think we can go with that for now. Thank you so much for the questions. I've got a lot of questions about incoherent mesh, talking about the Autodesk error that comes after verification. I have Horace, you share your screen when the time comes so that we can guide you accordingly. Then Tom talked about the soft weight. Then Philip talking about the wind loading, the logical wind loadings. I think we can start from there. Captain Abraham, are you in a position to say hello to us? Captain Abraham? Okay, I think he's not in a...
Hello, Deogratius.
Hello, Captain.
Good evening, Engineer.
Good evening.
Yes, good evening, everyone. I hope you're all fine. Yeah, I've been listening in, and yeah, it's a pleasure to have you once again.
Okay, thank you so much, Captain Abraham, for your regards. Captain Gatimu, are you on call? Captain Gatim, are you with us?
Hello, engineer. I hope you are well. I hope everyone is doing okay. I am with you.
Okay. Thank you so much. Maybe I'll give you some time to set up, or you're good to go.
Just give me a minute. Let Abraham take over, and then I will proceed after him.
Okay. Thank you.
Thank you so much, Deogratius.
Thank you. Captain Abraham, I think I request that you take us up from for the first session of the questions that we have today. We had a question coming up about the incoherent meshes. Then someone also asked about, does column alignment also have an effect on the does it play a part in the incoherent mesh error? Then also asked about, is there a way of doing a general slab check when you're working with the robot structure analysis? Then Bello and Melissa talked about an Autodesk error that comes up when you're verifying. Okay. Then Tom talked about he's facing a challenge with self-weight. His self-weight seems not to be loaded on his structure, so he's seeking help on that. Then Philip wants us to recap briefly about wing loading on a structure. I request you to take up from there. Thank you so much.
All right. Thank you so much, Engineer Deogratius, for hosting us for the first interaction. Good evening, everyone. Good evening, engineers. I hope you are doing great. Deogratius, I hope I'm audible. I always have internet issues.
Yes, you're audible.
So let me share my screen. I hope my screen is visible on your side.
It's still coming up. Okay, it's now visible.
All right, so I'm going to answer a few questions on column positioning, the slab check, and then Engineer Gatima will take on the incoherent mesh and other things. So column positioning, yes, it might affect your mesh depending on still how you model other joining elements. Let me first turn off the mesh. So this is a deliverable from one of the participants. This is a deliverable from one of the participants. But as we said earlier on, as Engineer Gatimo highlighted, when we start solving meshing at this stage, you have to do a lot of work. You have to solve it flow by flow. It is much easier when you're still having one flow because you adjust and then just copy the mesh that has been, that you are sure that it is fair or it is good. So, for example, if I go to the plan and I turn on the mesh, you just come back here. I think we are now used to these steps. if I turn on the mesh, you can see some few things. For example, I'm on, let me filter out the last story so that it's what I see. Now, for example, if I was to collect this, I have to collect it on the 6th floor, the 5th floor, 4th, up to down, because I have to trace it. But as Engineer Gatimo and I have always said, wherever you have
that's the kind of story that would stand in the jail for a year. I hope a lot of person because he's no man.
wherever you have meshing issues, one, you have to zoom in and try to identify exactly where did you snap to. Because as we noted, every point you snap to means a lot in robot. We talked about the circle, we talked about the rhombus, we talked about the triangle and what they mean, so that when your cursor turns into something, you know you're snapping to something. Why we always encourage you snap to when you have a rhombus, because initially what you have in your drawing from the start are the grids. So when you snap, when you have a rhombus, you're sure you have snapped at the grid intersection. And before you snap, always go to view and turn off the, there are small, I will just click in space. There is other small, I think they are turned off. Yeah, always come to view and turn off. For example, when I turn them on, okay, I'll turn them. There are small grids that are displayed in the software. You turn them off so that you don't, by mistake, snap at those small grids. Now, if we go back here, as I said, if we are to trace this, we are on the 6th floor, it would take some time because you have to trace it on the 5th, 4th, 3rd, 2nd. So this is column. It has been positioned. There is a beam here, there is a beam here, there is a beam, there is a beam, but it is not loaded at its centroid, but it is loaded at this point. What it means, this beam should not stop anywhere, maybe along the face. You have to pull it and it also intersects at this point. Meaning you're going to have beams that are intersecting at one point. So yes, the column positioning affects, it could affect your mesh. Still, if it was me and there are no constraints on any side, I would position this at the center so that it is loaded at its centroid. But if you decide to position it like this, then you have to make sure you snap to the right points. For example, if I zoom in, you can see this is a panel, but it has gone past the point where the other beams are intersecting. And actually, when you still click on this, you can see you have two panels that are overlapping. I think if I had earlier positioned this at its centroid, then I would be snapping at the its centroid. I don't know whether it would be easier to snap to its center, but however you've positioned it, you should be sure at what point you're going to snap. So yes, you will have issues here with your mesh because there are two panels that are not joining at the same point. As you can see, they would all join here, but one goes beyond. So you would need to pull it back. But even if you pull it back, you would have to trace it to all other floors. And also, you have to probably go back this side and just confirm whether you also snapped at the right point. So, but this is done during modeling. When we are modeling, this is when we make sure that we have snapped at the right points. And also, for example, if I was to regenerate mesh for this, because now it has very many elements, it would take forever because now it would redo the meshing for all these elements, which are very many, so it would take forever. I've also encountered I think it was raised by Engineer Bero, but I've only encountered it if at all I have the entire model and I want to change, for example, this, if I want to adjust these panels. Yes, I've also experienced that the software just crashes. We always advise you, whatever change you do, you save. So currently what we have, as you can see, we have 80,104 nodes. Remember, the machine size you have, the more data you have in your software, so how loaded it is. I don't know if Engineer Gatimo has any say on that, but yeah, I've experienced it when you try to adjust things when you have a lot of elements. I think what we said earlier on, when I was still having the first floor, there was no issue, but now when you have more elements, when you try to adjust things, there are cases when the software just crashes. It just randomly stops everything. On self-weight, if you area had self-weight, it is okay even if you have new slabs or panels that have come in where you already had self-weight. What happens, you shouldn't panic if you adjust and add any new panels, yet you had earlier input your self-weight. It is still okay, you just proceed. What the software does, whenever you run the calculation, the software recalculates self-weight for all the elements that you have in your model. So if you earlier introduced a new element and probably you don't see it showing the self-weight, you shouldn't panic, you just proceed. The moment you reach a time of running your calculation, what the software does first, it runs the self-weight throughout all elements, it recalculates the self-weight. Because remember, these small adjustments we do, for example, if I was to adjust this panel, literally I've changed the area of this panel. So its self-weight has to change, but you don't need to worry about it. The moment you hit the calculation, the software rechecks all panels, even those that had self-weight earlier on. The new ones you have introduced, it recalculates the self-weight. The only catch would be if you deleted self-weight. I've not encountered that if you entirely deleted self-weight and reintroduced it, maybe Engineer Gatimo can have an extra say on that. But whatever adjustments we are making, we are adjusting the area of that specific panel. So yes, the self-weight is changing. The moment you run the calculation, the software runs a calculation for all elements once again, because yes, due to the meshing, you would have adjusted a few things. So it runs the calculation for the self-weight once again. Slab check. When now we have such a model that has very many elements, it becomes very tricky. But as we earlier said, it is much easier when you're still having for example, when you're still having, I'm just filtering out, when you still have, for example, this one flow, it is much easier. Still, it goes back to modeling. And this is why I think we had to do a recap on modeling, because initially what you have in your model are these grids and stories that you have set. The moment you set the grids, you have now a new point that has been introduced in your model, the grid intersection. So every element you're pressing, now you'll be pressing it at the grid intersection. If you need to rotate it, move it, we saw how you do it, but the basis would be you're moving it from the grid intersection. Now, if we have pressed the columns at the grid intersection, then that should be the basis to press all other proceeding elements. If I'm to press the next beam, it would run from the grid intersection to another grid intersection where the column is. Unless that column has been moved, then you would run it from that other grid where the column has been moved to. Note you can as well introduce other grids. If, for example, you move the column, you can introduce a new grid at that specific location. We saw that. So since the area point you have is a grid intersection, that should be the basis of you placing all other entities, elements. So if I was to place this slab, because I had the grid intersection here, grid intersection here, grid intersection here, and it's very easy because initially what I have are grid intersections. The moment you introduce columns, you know you have to now have the circle and the triangle. The circle, which means the node, because you have introduced a column that has a node, and it has a member which is a triangle. So when I'm pressing this tab, I will place it at the grid intersection that I earlier on positioned the column. So That is basically the major check as you're pressing your slabs. Now, if you follow that, you're sure that all the slabs that you have placed on this floor, you have been placing them at the grid intersection where you earlier placed the columns. That would be your only check as you're modeling, because now from there onwards, if you pressed them at the grid intersection, it will be at the grid intersection. Even if you zoom in, you won't find any small gaps because you've been pressing them at that same point. So that would be the basis of you checking, but you only do that as you're modeling. Now, all other checks will come in the meshing, because now the meshing will tell you whether exactly the weight of this specific slab is being transferred very well. It is interacting with all other nearby elements, because it has to interact with all other elements. As we said, the meshing is like a skeleton that is embedded beneath your element that is going to transfer the different loads that have been subjected to that specific element. So I would answer the slab check that you would only be sure that you're pressing them at the grid intersection. That would be your check, because as you're positioning them, you'll position them at your grid check. You just make sure you're positioning them at the same. The other checks come in later with meshing, just to make sure there is interaction between the different elements. I'm going to call Engineer Gatimo maybe to throw more light in the same spirit. Engineer Deogracius, I think you can invite Engineer Gatimo. Yes, Engineer Gatimo, you can take it away. Good evening.
Abraham. Good evening. I hope I'm audible.
Yes, you are.
I think, Engineer, you've covered. Super. I think you've covered everything in depth or at depth. So with that regards, I do not have anything to add on that topic. I think now it's quite understandable, and I hope our participants have been able to understand that. So what I will do is I will open the floor to questions. If you have a question that is in line with what Engineer Abraham has presented on, that is with creating the meshes and getting to correct them, please unmute and share them with us so that we can let engineer take them before so that engineer can take them. And then if you have any other errors that they are yet to be covered, okay, or if your captain just highlighted a few errors that need to be addressed in this session, just type them in the chat box, and then we are going to be addressing them one by one. All right. So that's the goal for this session. We want to ensure that by the end of today's session, we are all comfortable with the models we have, so that on Friday we can do our analysis, read the results, and then next week will be the design part. So the design part in robot is really, really easy. The most important thing to do now is to ensure that our analysis is done accurately. Okay, so that is the task at hand. So if you have any challenge, I know from my DeepCube I have highlighted some. I've also texted a few of you to tell you that we are going to address your issues today. So don't worry, just raise them in the chat box so that if I may miss them as I go through the files I have, we ensure that we go or we address everyone's errors. And then the other thing that I have to reiterate at this point is that some of these errors are inconsequential. Say those errors that arise due to the cladding that we have, those errors are inconsequential because the cladding itself is not a structural element and it would not affect our structural integrity by any means. So errors that will arise due to instances such as the cladding, those are inconsequential, and you can you can just assume them and proceed with your design. But then they are limited. We are going to give you we are going to highlight two. I think there are only two or three errors that you can assume and proceed with your design. And then for the others, we are going to address them. All right. So if you have an error, that it pertains to meshing or creating the mesh and the overlapping panels, please feel free to unmute, raise them so that we can address them now. Please feel free to raise them. Please let us address them right now.
Hello, Captain.
Hello, dear gracious.
Yes, I heard Horace wanted to share his screen to show us where his problem could be. I don't know if he's in a position to share his screen. Horace?
Okay. Okay.
Yes, maybe, okay.
Are
Hello.
you in a position to share your screen?
Okay, that will be possible if I share.
Okay.
Super. Just a moment, Horace.
Okay.
Are they
Yes.
the errors that we are those the errors that we had talked about?
Yes. Yeah, the column missing properties where I'm stuck at.
Okay, no worries. Let me present on my end, then you can try it on your end, and then if it works, then we'll be all good, right?
Thank you.
Super.
I think
So,
it's in the same assignment I shared. Okay. You had said you'd cover it. It's good.
so
It's okay.
super. So let me
Thank you.
start. I will thank you, Horace. So I'll start. I'll share my screen. Then if you can see my screen, please type a one. Nice robot. Please type a one if you can see my screen. Let me know that we are together. Let me know that we are together. Super. So for you to get to see the errors that your model may have, all you have to do is go to analysis, and then from analysis, you go to verification. The software is going to run a verification, just a quick one, to get so that it can highlight the modeling errors. Okay, so these errors that are going to be shown here, they're just modeling errors. There are a few things that the software is trying to highlight to you, just to bring them to your attention. So the first one is members without properties, and then this one normally arises when a cross section was not either defined correctly or your software has issues. Okay, so this one can arise because of two issues: either you did not define your sections correctly, or majorly because your software is misbehaving. So that can happen. All right, and then the other thing that I'd like to address before I proceed is that for the guys whose software is crashing abruptly, please do this. Go to your settings, then go to storage. Please delete the temporary files that you have. Okay. If you have a lot of temporary files, they usually make your system a bit trash and they cause your system to misbehave. So you can just go to settings. Let me show you how you do that. So you go to settings, and then from settings, you go to storage. And then from storage, you're going to have the temporary files here. All right, so once they have been calculated, click on this delete, and it will calculate the temporary files. So if that doesn't work, please ensure you reach out to us so that he can assist you with the software, or so that he can be able to diagnose your system, right? But before you do, just delete the temporary files and then proceed with the tasks and then see if that works. So the first error that I want us to work on is the members without properties. And as we had said, this is an issue with the cross-section itself. So what you can do with this is try to identify which cross-sections these are. All right. So I can see here we have a beam. I can see here we have a beam. So there is that beam with an error, and then I can also see this column here. All right. So I'll just click on close, and then I'll try to identify what those members are. So for example, for this member here, I highly suspect that it does not have any properties. Okay. So if I was to select this column here and then get to see its section, let me see if it has a name. You can see it has no section. All right. So that's why the software is showing that this member here has no properties. It's just, I don't understand what it is. It may arise due to an error with the software, but sometimes it happens. So if this happens, just look at it, and then once you go to the properties, you can get to see that under the section it is written NA. That is that section there has no properties, or you created a cross section and then you deleted it. So if you deleted a cross section that you had already modeled in the software, you're going to get that error. So this is how it would appear. So if you have this, just select that member and then click on this drop down and get to select a suitable replacement. So if it's that section there, replace it with a column, and then for this other section here, this other section, replace it with a similar cross section or a suitable cross section. Okay, so that's how you do it. You just select it and then you go to the properties, to the properties panel, and you get to see it. So I want us to run another verification so that you can see how that works. So if I was to select members without properties, you can see that section that we replaced is no longer selected because it now has properties. So what you have to do at this point is get to identify which cross-section you want to use for these members. All right. So for example, for these members here, these columns here, I would want to use, I think we had used the 200 by 450 millimeter cross-section. So what we can do here is we can replace the entire 200 by 450 millimeters cross-section. So I'm going to go to columns, and then I'm going to define a new section. Yeah.
Yes, I
hello.
wanted to say something before you proceed.
Okay.
Usually what brings that is a participant choosing a section to use and they forget to choose the material. So the software can't identify which material you're going to use. In most cases, when you select all those that have that issue, you realize they don't have any material specified. So it is at the modeling, the participant just forgot to check the material to use.
Okay, engineer. So thank you, Engineer Abraham, for that. So I'm going to replace these sections here, these columns here that have that error. So I think the easiest thing to do is to just create a new section and then replace them. So what you're going to do first is select these columns, go to columns, and then you're going to define a new section. So here, what you have to do is ensure that the section type is column, ensure there is a material defined, and then you define the other dimensions. So we are working with 200 by 450 for now, all right? And then in the name, I can provide it with a name that I will understand. Say, let me give it column 1 so that it's now different from what I had with the others. And then I'll just do that. I will add it, and then I will close it. All right. And then after I close it, to make this easier, so that in case someone has the same error and they had already replicated the entire structure, instead of you having to select all the elements one by one, what you should do is go to the member selection over here. And then once you go to member selection, go to the section that had the error. We had seen it was CR 200 by 450. Then click on it, then click on these two arrows pointing upwards. And after you click on them, go to the geometry. Okay, go to the geometry, and then under properties, select the section you created, the new section you have created. So you have selected column R1 200 by 450, and then change it, and then just click somewhere in this panel, click anywhere, and then close. All right. Then I run another verification just to confirm if the changes you've made have been applied. So if you were now to do this, it still exists. So let's see what we have here. Okay. Okay, so I can see what happened here. So I think, engineer, what happened here is that you had a section that was deleted, and then after you deleted that section, you modeled other columns in the same position without changing these materials. So there's a column that is okay, and then there's this section here that is not, that has no properties. All right. So if you select this and then assign it, say any new section, and then you try to run a verification, then you're going to notice that this one has been solved. All right. So I think that's the issue. With your model. So what you should do for you is delete these elements, these columns here, so that you remain only with the sections that do not have properties. All right. And then okay, so this is my assumption because I don't know, I wasn't there as you were modeling. So my assumption is that you deleted a cross section, and then after you deleted that cross section, there were remnants that remained. And then from those remnants, or from there, you also modeled new columns that hit these elements. Okay, and then those, the cross-section remnants from the cross-sections that were deleted are the ones that do not have properties. So I want you to delete the columns from the areas that are being highlighted, so that you remain with these vertical, lines. Let me call them lines because they have no properties. And then after you do this, I want you to select them. So I can actually select one of them, right click, and select similar by member type. Okay, it selects all the columns. So unfortunately, you have to do this one by one. So just press Control and continue to select all of them. So you can see initially they were columns. The software identifies that they were columns initially, but something happened as this was being modeled. All right, so select all of them slowly by slowly. Don't be in a hurry. Please don't be in a hurry. Remember, it's easier to resolve these errors at this level. And then after you've selected them, change the section to something else. So say 200 by 450. Okay. And then after you do that, just press Escape, then go to Analysis, run a verification, verify, and then click on the members without properties, and you're going to notice that the columns have been resolved. All right. So the other thing that you have to check out is this beam here. Okay, that has no cross section, and then you should resolve it as well. So you'll resolve it in a similar way. And then as you do this, I'd recommend for the columns that are oriented in a different direction, please ensure you do the same. So you could just select them from here. Okay, select them from here. You can select them from here. Okay, so slowly select all of them. I think these ones were oriented. We had rotated them by 90 degrees. Then enter the angle here, and then do this. And then After you've done this, please move them by the distance we had moved them by. So that distance was, let me see the plan view. So there are these columns here. We had moved them, I think, downwards by 125 mm. So with them still selected, you can go to edit type and then move stroke copy. Ensure you select move and then move them by the translation vector 0, negative 0.125, negative 0.125, and then 0. And then after you've done that, just execute. Okay, after you've done that, just execute. Then go to the view, try to rotate this, and then you should have something that, looks a bit better. But then if it doesn't connect, please remodel the columns in this section. Please remodel the columns in this section, and then you can proceed to create to rotate them again. All right. So I think the problem here is that I have used a smaller section than you had used initially. That's why it is not connecting with these other beams. Or let me make it easier for you. So in this section where it's not connecting properly, like this section here, you can see here it connects well. Here we have a good connection, we have a good connection over here, and you also have a good connection over here. So this area where they are not connecting, just select them. Okay, just select them or identify them, and then go to the plan view. So let's see where that was. It's this section here. So you have this beam here. So click on it twice. Sorry. Click on it. And then have it at the node. So you could have it at the center or have it at this other node. So where you have that polygon, dock it there, and you should be good to go. And then for this other one that doesn't have the section, please select it. The section is name and change its properties. Change its properties, and then after you've done that, select it, and then go to this other top. Just left click once, and then once you do, you're going to have the option to dock it somewhere else. Then this one will change. So just do what you've done before. You're supposed to be supported at this point. Then proceed to do that. All right. And then for the slab, you can make the same edits. So let's see if this, or the problem here is that this is an entire panel. And then this is something that we do not recommend. It's going to make your mesh look a bit messy. We recommend that you have your panels being supported by individual beams. Don't let them cross the beams like this. The software will try to break down or transfer the loads here. Not that it will not work, but if you want a mesh that looks a bit better, avoid this. All right. And then now we can go to our view, and you can see it connects a bit better here. All right. So it connects better, and you can do the same on this other end here. And then if you run your verification again, then the error that was members without properties does not appear. All right. And then the other error we have is isolated overlapping members, that is beams and columns, are not allowed in the calculation model. That is, you cannot have a beam and a column in the same position. Two beams in the same position. Say at this position, you have probably a beam running up to this point, and then you have another beam, probably not even running through the entire length of the other beam, but just a portion of it is overlapping with the other one. So that one is not allowed in the calculation model because it would not make sense for the software for you to have something like that. So what you have to do at this point is just go to the plan view, Okay. Once you go to the plan view, click on this error here, which is going to highlight all the members that are affected by this particular error. All right. It's going to highlight all the members that are affected by this particular error. So once you have these, there are two things you can do here. One, you can either delete those members so that you can remodel them correctly, or once you have identified them. So let me try to zoom out. Let me try to zoom out so that I can see what we have. So just a moment. Okay, so I'll close this. So I know this is where the error is. I know that's where the error is. So I'll select this beam here. I get to see where it is ending. And then you're going to see that most of the time this is what happens, that you have a portion of this beam going into the other beam. All right, so that is usually what happens. So we also have another beam here. And if you look keenly, we also have another beam there. So we have multiple beams at the same point, and then that's what is causing the error. So you can delete some of them. Just zoom in. Try to delete some of them, or delete all the beams in this position, and you only select the beams. Yeah, so I don't think I have any more beams at that point. You can use the 3D view to confirm. You can see I have no other beams in that section. Then once I am sure of these, I can remodel the other beam. So I can just go to beam and then model another beam at this section here. Okay. And then this is what you have to be careful with these kind of things. Try to ensure that the columns or the beams that join in your columns are going to these nodes here and not to these other nodes that may be formed as you model the beams. So having them near them, along the axis, say this axis in this direction, and then this axis in this direction, it makes your modeling easier. What this will do, it will create a lot of eccentricity in your column design. So try as much as possible as you're snapping on your beams, and at least try to make sure that the snapping is done along the axis, either the major axis of the column or along the minor axis at least. All right. So that's where that is allowed. And then where you have an eccentricity, just ensure it's along an axis, basically. And then once you have that, you can model the beam there. And then for the overlapping slabs, such as these ones, so you can see these two slabs overlap. You have this slab overlapping on this one, and then this one going into this one. So Engineer Abraham has covered these quite at depth. So all you have to do is select the panel, then click on the slab itself. And then once you do this, snap on the correct. Oh, my software crashed. So just a moment. Okay, so I hope it won't trouble me much. So for those sections, as engineer has highlighted, just select them. And then once you select them, use this plus icon to move them. Okay, so that's happening a lot. I think I won't use that model. It may be corrupted. Okay, so we have that. Abraham, is that okay? Do you have anything to add on that topic?
No, you've covered all the issues Basically, the participants have to take care while modeling because everything comes from how we model. The different points we snap to, as you've highlighted.
Okay. Thank you, engineer. Then the other errors that may be appearing. Let me get to see through the chat box. Okay, Horace, I believe we have tackled your issue as well.
On my end, I know there are columns I deleted, some I changed.
Yeah.
So as you've highlighted, I'll need to go through them, and if I'll need to model new ones, and then if in case I'll have an issue, I'll get back to you.
Okay.
Thank you.
Let me see. Super. You are welcome. Let me get to see someone else. I'm reading the chat box, so if you have any errors, please raise them in the chat box. When correcting the machine. Oh, there was error with the dead load, with the self weight. Let me look for that. Who was that? Yeah, here it is. Okay, so this is one of the things that I have noticed. Your model may look quite okay. You may actually run a verification, and it will appear that you have a clean bill of health. All right, that may happen, but it's always good to look at your model, get to look at it at depth, and get to understand what is happening in the background. Okay, so this is what I want you to do. This is what I want you to do. So if you go to your loads, and then you go to the load table, all the loads that have been defined should be here. All right. All the loads that have been defined should be in the load table. So you can see my friend here has all the loads that he has defined, which is okay. But one major load is missing. And the load that is missing is the self weight. So you can see all the load cases are here, and they start from 2. And then we have repetitions of partitions. So probably he assigned them one by one. That's why they appear this way. Then they start. Okay. So you can notice that the self weight is missing. Okay. So if this happens, probably someone may delete it by mistake. Probably the software might misbehave. So if that happens, this is all you need to do. It's actually really simple to reload the structure with a self weight. All you have to do is go to loads, and then from loads you go to load definition. And then from load definition, you go to self weight and mass. And then from self weight and mass, you click on the first option. So the first option loads the self weight of the structure. And then once I do that, if I was to let me turn off section shapes, you can see the orange highlight that shows you have the self weight. Okay, and then apply and close, and you're good to go. So by that, if we go back to the load table and check the load, we go to the load table, we are going to see that we have the self weight, which is applied to the entire structure. All right, and the direction is -z. Okay, so that's one thing you can ensure. And then the beauty of this is that a robot does not allow you to duplicate the self weight. Okay, robot does not allow you to duplicate the self weight. So now that I have the self weight, if I went to loads, and then I went to load definition, and then from load definition, if I tried to load the self weight, if it has the self weight, I cannot click on this. Okay, you can see it is highlight. It is grayed out. You cannot access it. All right. So if you have any issues with the self weight, please get to do that. And then if you are not sure, just go to loads. And then once you go to loads, go to the load table. And from the load table, you're going to see all the loads that you have. Some may be repeating because you assigned them separately. Say you deleted a beam, then you went to assign the new beam the exterior wall load, then you're going to have two exterior wall loads. So that does not mean that you made any error. But the error that you can see here is that you have a missing self weight. Okay, so I think that was the other grave mistake or a grave error that I may have observed. Then the other one was with these two errors that we are getting with this structure. So with this structure, we are getting two errors. Let it finish its verification. Is my laptop hot, or why is it taking long to do this? Okay, so we are getting to these two errors. The first one is the incoherent mesh on edges. Engineer Abraham has covered this at depth. Then we are going to discuss something small on this. Then the second one is the tolerance may be too large due to the dimensions. That is, the tolerance that the software has assigned your structure is too small as compared to the size of your structure. So if you get this, all you have to do is go to analysis, and then from analysis, you go to analysis types. And then from analysis types, you go to structure model. And then from here, you increase the tolerance. So you can use a value between 5 and 10. So if you use 5 or 10, that works. Then click on close and rerun the verification. Okay. So once you rerun the verification, that error should disappear. Again, just give it a moment to complete. Okay, so you can see it disappears. That's how you take care of that error. Then the other one is with the incoherent meshes. So a robot is a very funny software. So there are these small incoherent mesh edges that will appear as you copy your slabs the other floors. If you are very sure that you had solved all the meshes as you are, the mesh errors as you are in the first floor, and then they reappear in the other, some new ones reappear in the other floors, especially if they are this small, then they should not cause you any concern. You can choose to delete them. So you can click on them. You can click on this twice, and then once you click on that twice, the software is going to highlight them, and then just delete those minor meshes, and then verify your structure. And then once you verify them, you should notice that the errors will majorly disappear. Okay, so let me go through my deep cube again. Let me see if there's something I had raised. I think I've tackled most of the issues that I had raised. With regards to overlapping panels, we have solved that. With regards to, yeah, let me open this one. Okay, so I'll select all nodes, and then I will delete the nodes. Just a moment. Let me delete the nodes here. At this point, it's going to be really heavy. So I rerun the verification. I rerun the verification. Okay, so I still have this error. So I'm going to select it again. And then you can see that the edges that are being formed are really, really tiny. So what I'll do with this is that I'll click on this delete icon over here. All right. So for those Yeah. Sorry for that. I just lost power as I took a minute to buy some bundles. So I will continue to reshare my screen. Okay, so let me share. Okay, so as we were doing earlier, we were just correcting the incoherent mesh. So you just click on the error itself to select the meshes. And then once they are selected, you can even click on open a new window. If they are not visible, let's see. Okay, so if you click on this, they become visible. And then from here, you can, so from here, you can highlight them and then just delete them. Okay, and then you can exit from this, go back to your structure and verify again. So you have to do a couple of iterations, especially with the with the small elements. They're usually due to very, very small inaccuracies. They're usually due to the very, very small inaccuracies as you model. So that happens, and then if they're insignificant, then you can delete some of them. But if they appear as you do the meshing on the single floor slab that you had, then it's advisable you just correct them from there. But if they're small, you can just delete them. Okay, so I will go back to Telegram, get to see if we have any more errors. Okay, or if anyone has a question, please raise it. If you have a question with any errors that you have faced up to this point, please raise them. Let me get to see if there are errors that I had. Oh, there's this error here by Viola. Let me see. Okay. So most of them we have already resolved. For most of them we have already resolved. So the other one with the kinematics, I will try and resolve it right now. The one with the kinematics, I will try and resolve it right now. So let me try and look for Viola's drawing. Viola, can you reshare your milestone 2, or was it milestone 3? I'm not sure if I still have access to it. Okay. Let me see where that was. Okay, or if you have an error that you don't want us to share to resolve right now, just share it in the Telegram channel, and then our team will let us know that we have a file that we need to look at. Okay, let me see if we have. Okay. Okay. Okay, I think we've resolved most of them that we have found up to this point. I think we've resolved most of them. So I'd like to open the meeting to anyone with a question with regards to resolving the errors, and then from there we are going to proceed. Okay. So anyone with an error that we are ready to resolve? Anyone? Are we all good? Are we all good? Please treat this as the feedback session. On Friday, we are not going to have a feedback session. We are going to have a training session. So treat this as the feedback session so that at least we can save time.
Hello, engineer. Good evening.
Good evening, engineer. How are you doing?
I'm good.
Okay.
I have an error of separate structures. I don't know how I can go about it.
All right. Are you in a position to share your screen? Or would you like to share the model?
Let
Which
me
one do you
share the
prefer?
let me share the model to
Right.
the
Okay, so the error of separate structures usually appears when you have an element that is either too small, as compared to the other members in your structure, or it has I don't know if the minute sections is is I would describe it better, but it has just some minute properties as compared to the others. So what you need to do when that happens, you need to identify the nodes that are being highlighted as being part of the separate structure. And then once you identify those nodes, you can be able to either get to inspect the member. Then if it is important, you get to assign it the correct properties. And then if it is a non-issue, or if it's just a member that was either modeled wrongly or by mistake, you can just get to delete it. Yep, so engineer, we will be waiting.
I'm trying, my laptop is a bit frozen. I'm trying to, let me try to share.
No worries. I would suggest in the meantime, as you wait for engineer to share, just take a moment, look at your model, look at your file, and then as you look at your file, let's get to see if there are any new errors that we are yet to resolve. And then from there, we are going to do our analysis on Friday. And then as you do your analysis, you're definitely going to run into a few more errors, but you're going to resolve them as well. But Engineer Abraham?
Yes, engineer.
Okay, so for the errors that arise during analysis, I'd like to recommend we have individual meetings in the DeepCube so that we can, at a time of that is convenient to all members of each DeepCube, so that we can proceed with the training on Monday, so that we can at least get back on schedule. What do you think?
It's all right.
Okay, so I think Engineer Abraham will plan with DeepCube 1 so that you can, after everyone in DeepCube 1 has done the analysis, you can have a joint meeting, all of you, get to resolve them. And then I will plan for my own meeting with DeepCube number 2 so that we can resolve all of them. And then from Monday, now we start doing the design one.
Hello, engineer. I've shared it in DeepCube 1.
All right, let me open it. Just a moment. Yes, so I will share. Titus, please confirm that you can see my screen.
Yes, I can see your screen.
So I'll just check this to the 3D view. Then I will turn off the machine so that it's a bit easier to see. And then I'll go to analysis, verification. Is this the correct file?
Not really. It is not the correct file.
Okay.
I had copied up to the 5th floor. I don't know what happened.
No worries. Probably if your software is still open, you can just save it again and then reshare that file.
Okay.
Yes, so please don't shy away from sharing any errors. Remember, the main errors that we solve are the likelihood of you facing an error in the future that we will not take you through reduces. Okay, so if you don't share your errors, you're not only you're not only sorry, I lost my words. You are not only denying yourself an opportunity to learn, but you're also denying everyone else an opportunity to learn. So if you have any errors that you are yet to resolve, please raise them. Please raise them so that we can be able to do this.
Hello, engineer.
Hello, engineer.
Yeah, please, good evening. I want to know whether the error of the incoherent boundary edges, whether it has been resolved.
Okay, so the error of the incoherent boundary edges, I think we discussed it earlier, we say that it arises due to, okay, let me get to see your file. I don't want to. Okay, let me see. Did you share it in DeepCube too? Hello? Samuel?
Yeah, engineer. Yes, please.
Was it shared in DeepCube 2 or which DeepCube did you
Yeah,
share your file name?
Engineer, please, DeepCube 2.
Okay, let me try and look for your one.
Yeah, that's Samuel Nketioware.
Okay. Let me see. I don't know if I'm scrolling too fast, but I cannot find your, okay. Here it is. Okay. Samuel, please confirm this is your latest submission.
Yes, please. This is the latest.
Super. So I will run a verification. Let's get to see what error we are talking about. Okay, so for this particular error, I think we have spent so much time on it. So just click on this. Just click on this error here. And then once you click on this, you're going to see the highlighted errors or the highlighted areas where you have this incoherent mesh. So at this point, before you get to replicate this floor plan to the other floors, it's important that you ensure you do not have these incoherent mesh on edges. So it could be caused by a couple of things. Number one, majorly how you've modeled it, and then the nodes on these areas, okay? So if I was to look at these, I can see, let's say we have this beam here, okay? And then we have a node here. So these nodes are the ones that could be giving you these type of errors. So you could just delete. First, let's delete all all the nodes just to ensure we do not have any any isolated nodes, and then look at the panels if they have been modeled correctly. So I think with that one, it looks a bit correct. Then that one looks quite okay. Yeah. So we have that. Then let me see if we have a beam here. Okay, so we have a beam there. I think it has a good section. And then the other thing that I need to look at is how this beam has been supported so that we don't have, okay, so I think that's quite okay. Okay, so once you've deleted those extra nodes, what you can do is just select, why is it going too far? So select the slabs that you want to try and remesh. So once you ensure they have been modeled okay, just go to the meshing options and locally delete those meshes, and then go to meshing. Ensure you enter an appropriate size. So let's use 0.25 for these. Then go to advanced. So you have 0.25. Okay, that is good. And then once you have that, generate the meshing for those two slabs there. I think I can already see a difference in the shape here. So you can now run the analysis. Let's not the analysis, the verification. I know some will still appear, but let's see if is these two. So you can see this one was resolved. This one was resolved. So you can do the same on these other ends. So these other ends where you still have the same, it should probably probably the meshing. So just select the slabs. Ensure first they have been modeled correctly. Ensure there are no nodes. Ensure there are no missing
engineers, I think we must have lost Engineer Gatimo. But all he was explaining, incoherent mesh, just make sure you have snapped to the right points. If you have a beam, make sure you have snapped along the beam. So there are different points we snap to for the slabs affect the mesh. Yeah, I think Engineer Gatimo is back. But yeah, that is what he was trying to demonstrate, how we model the different points we snap to. Make sure as you model the slabs, you've snapped to the right points. Engineer Gatimo, are you still there?
Yeah, I'm here. Sorry for that. I do not have power, so I'm trying to like balance the phone I was using for bundles. It also went off, so I had to connect with another device. Okay, so generally the tiny modeling errors are the ones that cause the incoherent mesh. So what you can do is wherever there are these boundaries with a meshing, just try to delete those panels. So delete this select that panel, then reselect this panel, delete the mesh, and then just check out this, ensure it has been set appropriately. Click on OK, and then regenerate. Okay, so you're going to notice that those funny shapes disappear. So whenever you see these, for example, this portion here, so you can see that the mesh size for this particular slab and this one are different. And then if you get a weird shape such as this one, I'd like to know why these happened. Okay, so you can get to look at this, get to see if it has, it's snapping at the correct points, and then also look at the calculation model of the slab. Okay, so that one is shell. Then this one should also be shell. I think that's good enough. Then once you have these, please select these panels, delete the mesh, and then set it correctly. So let's work with 0.25. And then remesh them. So some cases it works. Let me get to understand why this one is different. So I'll just delete it again and then remesh it. Okay, so then you can keep running your verification just to ensure that the areas with the incoherent meshes are at least reducing. Okay, so you can see at this section we have resolved it. At this section you have resolved it. So you need to select the other sections with the same error. So just do this slowly. Do this slowly. It is majorly caused by how you model. So okay, so I don't know what happened there. Oh, I just zoom out. I just zoomed out. It is majorly caused by how we model it. Considering that it's your first time using the software, it could be the issue. All right, but just do this. Identify the areas with incoherent meshes, and then select those panels. Right, so I can select this panel here, and then with this panel here, then you have to ask yourself a question. Or we have a beam here. All right. So if you have a beam there, it's quite okay to have that panel that way. And then select the adjoining slabs. Okay, so let's see. So do this slowly by slowly, focusing on the panels that have issues, and then check the mesh settings. Reduce the size. If you're using a meter or 0.5, you can reduce them to 0.25 for greater accuracy or for more accuracy. And then once you have that, click on OK. And then once you click on OK, just regenerate the mesh in those instances. Okay. And then you can try and run a verification. Click on the incoherent mesh, and then you're going to see that every time you regenerate a mesh, the areas where you have the boundaries showing the incoherent mesh, they get resolved. Okay, so I don't think I have to do that, throughout the entire structure. You can just do it slowly by slowly. And then once you have resolved once you've ensured that no boundaries are incoherent, then you can proceed. Okay, engineer, have you taken note of that?
Yes, engineer, I've taken notes.
Okay, so it's that simple. Just select two slabs, delete the mesh locally, and then generate a mesh for those two slabs only. It's majorly due to the meshes are not continuous, or the software had a challenge with trying to mesh those areas. So you can just rerun them, and then it'll be good to go.
Well
Okay.
noted, engineer.
Okay, you're welcome. Titus?
Yes, I have
think you
reshared it.
had.
I have reshared
Okay.
my DeepCube one.
Okay, so let me open it on my end. Okay, it is just a moment for it to download.
Engineer Gatimu.
Yes.
There's a comment in the chat box, I think from Engineer Dan, with slanting columns.
Oh, okay, let me get. Would you take that on, or would you like me to take it? Don't think I can see the errors because I rejoined the chat. I can't see the chat.
I can take it on. You can finalize with that maybe.
Okay, so let me go to the view tab. Okay, now this is good progress, engineer. This is a really good progress. So this is what we will do. We will go to verification. And then we have these two errors. I think we have resolved this. Oh, engineer, your error comes during analysis, right? Engineer Titus?
Yes, my error comes during the analysis.
Okay. Due to the interest of time, can I record a video on that tomorrow?
Okay, no problem, no problem.
Okay. Engineer Abraham, you could take it on, and then we could close the session for today.
All right, let me share my screen. Let me open. I hope it was this one. Okay, I'll just turn off the mesh. So you can see, Engineer Dan, I hope you are there. You can see you have some slanting columns. I'm thinking this is your query. Engineer Dan, I hope it is.
Yes, that's my query. I had two slanting columns. I don't know what was causing that.
All right, so I'll just go back to the plan. I will turn off. There's a question still in the chat box in the node numbers when they appear. I can also address that. I don't know. You might have something like this. There's a participant that commented about node numbers. All you have to do is come here on the node numbers. This is where you get to display the node numbers. So all you have to do is click here, the node numbers will disappear, and you can as well turn off the display. So I think this space that has no visible column, and this is where you have slanting columns. To do this, the fastest way is I can select them in 3D. I'll hold down the control. You can see they're all oriented like this. I will just confirm this is okay. So I'm just going to delete these and replace them with a column that is okay. I just save time. So I'll just press the delete button on my keyboard. So I'm going to select this column that is not slanted, as you can see. After selecting it, I'm going to go to plan. Note, this is where we have deleted. I think it is here and here. So I'm going to go back to the plan view. Remember, I have this one selected. That is why it is in blue. I've selected it in 3D. So all I'm going to do, I'm going to launch the copy command. So I'm going to copy it from here to this point and the other point. So I will select it by the grid. So I'll just hover over this point. When I have a rhombus, I'll select it. It means I've selected it by the grid intersection. So when I come here, I will just zoom in and have the grid, then click. I can escape and okay, I'll close this. I can still select this from here. When I have it selected, I'll still launch the copy command. I'm going to also copy it by the node. I'll just slightly move away so that I copy by the grid intersection. Then I also come at this point where we deleted. I'll hover over. When I have the grid intersection, I'll snap. We shall go back in 3D to see what we've done. So I'll just close this. So this is what we've done. But now it looks like your columns down were offset away from this. So I'm going to go to the 1.5. I'm going to go to story 1.5 so that I see, you can see, I think the red columns, those are the ones we have positioned, and these ones are slightly away, the ones that are below. For example, if I select this and go back to the 3D, because I want to see it's this column, so it is away from this. I can change this from the 3D. I have it selected. Now I'll launch the move command. Okay, I can repeat this. So you just come back here. You remember how we displayed this? They come from the edit. So I'll launch the move command this time because I want to move it. The translation vector. Now, because this is a column that is not at any grid, the lower one, I'll snap it by its member end, the triangle. Then I'll move it to the grid because this other column we positioned it at the grid. So when I have the grid icon, I'll snap. But now the question is, why haven't they
merged well. So I think the cross sections, for example, when I select this is a 200 by 450. And when I select this, it's a 200 by 500. So otherwise, if you change this to, okay, I'll escape because I had earlier, if I'll escape, I have it selected. I don't know if you have a 200 by 450. I think you have. So I will adjust it to a 200 by 50. It would match. The same applies to this. All you have to do is select it. Okay, it's 200 by, let me first change it to 200 by 450 so that it matches this. Then I have it selected. You can see it in blue. I'll launch the move command. The translation vector. Remember, there is no grid here, so I'll snap to the triangle, which is the member end for this column, then move it to the grid intersection for this, and then close. So you'll be good to go. But please take note of the sections you're using. They have to be consistent. Yeah, for example, this is also slightly away. You can first interrogate it in plan. I will go back to story 2. I can select it in 3D, then we can see it better. I'll select this one just to confirm whether it's this one that has been positioned well or the one below. So I'll go back to the plan. It's right here. So it depends how you want to position it, because the one below is actually at the center, or it might not. So it depends on how you want to position it. But now when you start adjusting things within here, you have to do a lot of work. So this also goes back to modeling. Where we began from, that is like your benchmark. So that is where you change things from. If you're to change, for example, you want to move a column, if you had earlier added another column, you have to select the entire column at once before now you come and move it by maybe 150 or 200, whatever you want to move. You have to make sure the entire column is selected. Otherwise, you will move the one up and you leave the one down. So if you're moving things and you don't have maybe only one flow, you have another flow with elements, make sure you select the entire column from where you are, the level at which you are. The entire column should be selected before you move. Because I'm thinking what happened here, you moved the one above and left a portion of the one below. Yeah, but that is the fastest way that you could get to adjust this. I think you can see they now show up in your plan. Yeah, that is it, Engineer Gatimo.
Okay. Thank you. Thank you. I know at this time we have when running your first verification, then you're going to have another similar session such as this one, but now it is going to be DeepCube based. So DeepCube 1 is going to arrange and meet with Engineer Abraham, and then I'm going to arrange and meet with DeepCube number 2, so that we can also save our time and try to make progress. I hope you found this session insightful. I hope it will help you solve some of the errors or most of the errors that you ran into. And then after we run our analysis on Friday again, we are going to try and have another session. The goal is to expose you to as many errors as you can get. Okay, like we could have tried and went the easier route, that is to use a very clean model, probably one Engineer Abraham has modeled with, and then use it for the presentation. But then that would mean that you miss out on some very key insights that would affect how you use the software. Okay, so please don't shy off from sharing those errors. We are going to try as much as possible to resolve all of them, and then by resolving all of them, we are all going to learn. All right. So with that, I'd like to adjourn this session at this point, and then after Friday's analysis and going through the results, every DeepCube is is tasked with arranging their own meeting so that we can ensure we are on the same page and we have resolved all our errors, so that from next week you will have clean models to use for design. Okay. So that is that. Thank you for joining us tonight, and have a good night. And if we have not said these at this point, I think most of you are doing a really, really good job, and we are proud of the progress you are making. So thank you, and see you on Friday.